Okay, folks, so assignment number 26 is over logarithms, and I just need to say that there are a ton of different definitions related to logarithms, and my goal is for us to be very good at 4 of them. So we'll introduce 4 definitions of logarithms. They've been uploaded to you, and we can go through them fairly quickly. So just to have a rudimentary understanding of logarithms, and I want you again to know there are tons of properties and things we could talk about, but to me, the major definition is how to go back and forth between what's called exponential form and logarithmic form. You have the notes in front of you. 2 to the third power equals 8 would be an example of an exponential expression. And I want to remind you that the 2 would be called a base, all right, because anything with a power attached to it is called a base. The pattern, I feel this is, would be simply to say, all right, the definition of a logarithm would be, this is called the log base 2, not a coincidence that whatever the base is over there becomes the base of your logarithm. So we say the log base 2 of 8 equals 3. So we've already talked about the fact that whatever the base is over here becomes the base of your logarithm. And then the 8 is called the anti-log. And so basically following this pattern, whatever is the base over here becomes the base of your logarithm. The number on the other side is your anti-log, and the power ends up by itself. So just that pattern, we're going to practice that on example number 1 multiple times, basically following that pattern of changing one expression into the other. And once again, the idea would be that this base raised to this power equals the anti-log. So looking at that definition number 1, Roman numeral number 1, keep that in front of you, and now we will look at example number 1. Same idea, we give you an exponential expression, 3 to the 5th power equals 243. I would like to point out to you that that would be considered an exponential expression, much like the type over here, base power equals. So following that pattern, wouldn't that simply be the log base? I want to remind you the base, it looks a lot like a subscript, is whatever the base was over there, log base 3 of, in this case, the 243, and it would equal 5. So the pattern that hopefully establishes for you is that when you change it to a logarithm, the base raised to this power equals the anti-log. And that would be the logarithm dance. You won't be able to see my feet very well, but when you look at this over here and change it to that, you would hopefully say, oh, okay, the base raised to this power equals the anti-log. And that's our logarithm dance. Sorry, the camera's not pointed at my feet. You're probably happy that it's not. But basically, that's applying that pattern, that definition to the question. And that's it. That's it. Change it.
That was easy.
These are pretty easy here. So we just want you to understand this particular pattern, this particular definition, inside and out. All right, so x to the c power equals w. That again would be an exponential expression. That's why it's written in the exponential column. And again, following that pattern there, and I want to say this out loud, so you would say log base, you always say the word base to indicate this, and the base over here was x, so that would be the base of our logarithm, the log base x of, what do you guys think? Exactly, w equals c. And again, x to the c power equals w, x to the c power equals w. It fits the pattern of the definition. It fits the pattern of all the others. So again, I hope this is pretty easy for you. All right, next one. This time we give you a log, and I want to again be clear, the way you say this is the log base 5 of 25. We didn't tell you what it equals this time, did we? I did that on purpose. I'm hopeful by now you would look at that and say, if I was trying to figure out what that logarithm equaled, my brain ought to be thinking 5 to what power makes 25? And so you say, well, 5 to what power makes 25? Oh, second power. Yeah. That needs to be a 2 over there. I didn't forget to type it. I thought I'd give you one where you could think about it. Yeah, because 5 squared equals 25. This to that power equals that. That's the pattern on every one of these. That's the pattern on the definition. And that's the pattern we hope to establish on this first example here. So again, I might be running out of room, but I'm hopeful that you're following along. So moving right down the line, and I'm not here to, I usually would ask you to say this to me, so I'm listening. I hope you're saying to me right now, the log base Q, when you say base, that tells me it belongs down here. Make sure you say the word base. The log base Q of W equals M, same pattern. This is the base, you raise it to this power, and it equals this. So on the other column, that would be Q to the M power equals W. Again, I'm hopeful that this is all coming together very nicely. I can tell I'm running out of room. I might erase up here and make room for more examples. Okay, hit pause, do whatever you need to do. I gotta make some room. Okay, so I'll leave that first one up there. (16) to the negative 0.5 power equals 0.25. Notice is in the exponential column. We have a base raised to a power. And so what's that look like? And again, I know it's fairly new to you, but again, going back to that pattern underneath that definition, you would say log base, what's the base over here? 16. Log base 16. Make sure you now say of. Keep in mind that looks like a subscript, but the anti-log goes on the same line as log. Of what? 0.25. Yep. Equals negative 0.5. Let's confirm that. This to that power equals that. This to that power equals that. Yes. Yes. Awesome. These are easy. I hope you're looking at this going, man, I like these. We got several of these on the first page of assignment 26, and it's a building block. All right, and then this last one, the log base 16 of 4 equals 0.5. Change it to exponential. And again, your pattern to follow would be in definition number 1, and you would hopefully say, okay, 16 is your base, so 16 would be your base, raised to the power of 0.5 equals 4. Okay, so that would be example number 1, and I think we'll hit pause here and we'll come back and have another video where we'll continue the discussion and do example number 2. So I hope so far you're going, well, that's just a pattern to follow. That's easy.